As we move across this series, the filling of the d orbitals explains the characteristic properties and trends we observe in these elements.
Hello students, welcome back to my channel. Today's topic is D block elements. D block. So D block elements, where it is present in the periodic table, means these are present in between S and P block. S and P block elements, in between these D block elements are present. And next one, D block elements group numbers from 3 to 12th group. 3 to 12th groups are called D block elements. And next one, totally how many series are there, means totally 4 series are there. That is the 3D, 4D and 5D and 6D series are there. So 3 to 12th groups are called D block elements, and where it is present in between the S and P block elements. And how many series are there, means totally 4 series are there. 3D, 4D, 5D, 6D series are there. Now coming to the periodic table. So this is the S block, this is, and next one, this is the P block, and this is a D block. So S block, how many groups are there? First group and second group are S block, and 13 to 18 groups, those are the P block, and in middle, that is the 3 to 12th groups are D block elements. 3 to 12th groups. Now here totally how many series are there, means totally 4 series are there. This is the 3D series, and next one, this is the 4D, next this is the 5D and 6D series. So this is a totally 4 series are there. Now in this, how to give the name, means here this is the third group is also called, this is 3B, third 4 Roman numbers, that is the next 5B, 3B, this is 7B and 8B. So these 3 groups also 8B only. Next, this is 11th group is also called 1B. Next, 12th group is called 2B. So this is naming, means Roman numbers, in the Roman numbers. So here D block elements were also called transition elements. D block elements were called transition elements. So what is the correct definition of transition elements, means the atom which is in ground state or ionic state, any oxidation state, ground state or an ionic state, that atom is having incompletely filled d orbitals. Incompletely filled d orbitals are present, then it is a transition elements. Filled d orbitals or d subshell. Now here 12th group, if you are observed, 12th group, what are the elements? That is the zinc, cadmium and mercury. Zinc, cadmium, mercury. So if you are observed, these elements having D10 configuration. Here where it is present in the 12th group or 2B. Here zinc, cadmium, mercury, these are the 2B group elements. So 2B group elements having which configuration? D10 configuration. So that's why it is completely filled d orbital. So that's why it is, we are not calling this is 12th group is not a transition element. So 12th group elements except 12th group, remaining all are transition element only. The only 12th group is the non-transition elements. These are non-transition elements. Why? Because this 12th group having D10 completely filled d orbitals are present. So that's why it is a non-transition elements. So remaining actually D block from where to where? 3 to 12th are the 3 to 12th groups are the D block. But in this 3 to 11th group only we are calling as a transition elements. Only 12th group we are calling as a non-transition element. Non-transition elements. Why? Because it having D10 configuration, remaining having D1 to D9 configuration only. So it is a incomplete filled d orbital. So that's why these are called transition elements, and this is called non-transition elements. So this is about d block elements. Now electronic configuration, we are discussing about electronic configuration of d block elements. So what is the general configuration of d block elements? That is the n minus 1 d n minus 1 d 1 to 10, and next one n is 1 or 2, n is 1 or 2. So this is the electronic configuration of d block elements. But here only palladium only having what is the configuration? That is the 4s 5s0, means here krypton, and this is the krypton, that is the 36 elements, and next one 36, and next one 5d10 and 4s0, means this is only having s0 electrons, that is the palladium. Actually here what is the electronic configuration of d block elements? S1 or 2 electrons in s orbital, 1 or 2 electrons are present, but palladium having s0 electrons, 0 electrons. So this is the exception configuration, palladium. So now coming to the 3D series, totally four series are there. So on that we are, first of all we are discussing about 3D series electronic configuration we are discussing. So 3D series, what are the elements are present means in 3D series? 3D series means where it is present? Here, and observe that. So 3D series means from here to here, means scandium to zinc, those are the 3D series. So this 3D series electronic configuration we are discussing. How to write the electronic configuration? So first in 3D series, what is the first element? That is the scandium. Next after that scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So these are the 3D series elements. Now in this exceptional configuration, chromium and copper having exceptional configuration. So what is the exceptional configuration? I will explain. Now first of all, scandium configuration. Scandium, first of all write down atomic numbers. Scandium atomic number is the 21. This is 22, 23, like that. So now first scandium atomic number is 21, so it having 21 electrons are present, 21 electrons are present. So that 21 electrons how to fill? So 21, what is the nearest noble gas? That is the argon is the nearest noble gas. So argon if you are writing, then totally 18 electrons are completed. So this is argon we can write. After the argon, which shell will be filled means that is the 4s will fill, 4s after that 3D also will fill. So coming to scandium configuration, how many electrons we have? 21 electrons. So 21 electrons, out of 21, 18 electrons. If you kept the argon, totally 18 electrons are completed. After that, remaining 3 electrons we have to fill. Out of 21, 18 electrons completed. So remaining 3 electrons, so how to write that one? After that, 2 electrons are present in 4s2, and next one remaining 1 electron will be filled in the 3D. So now titanium configuration. Titanium, how many electrons it having? 22 electrons. So argon 18 completed. Then remaining 4 electrons in 4 is 2 electrons. Then remaining 2 electrons here 3d2. So what is the titanium configuration? Argon 4s2 3d2. Next vanadium is the 4s2. Argon completed 18, 18 plus 2 20, then remaining 3 electrons in the 3d3. So this is the 3d3 configuration. Next chromium, what is the atomic number? That is the 24, and 18 argon completed, then remaining 6 electrons are present, then 6 electrons you have to keep 2 electrons in the 4s, and remaining 4 electrons you have to keep in 3D, so 3d4. But here this is not exact correct configuration. Why? Because here d subshell is there. So d subshell having how many orbitals? 5 d orbitals. So if one electron is present in the 5 d orbitals, it is getting the what is that, like this d orbital. One electron, if it is filled, it is getting the half filled configuration. But here how many electrons are there? 4 electrons only is there. So one more electron, if it is present in the d orbital, then it is getting the half filled. Then it is getting the half filled configuration, means it is a stable. So to get the stability, what happened means, here in s orbital one electron is shifted to the d orbital. Then what is the configuration of that? 4s1 and 3d5 will come. So this is the exceptional configuration for chromium. Next, manganese. Manganese is the, what is the atomic number? 25. So 18 argon completed, then remaining 7 electrons. So 2 electrons in 4s and remaining 5 electrons in 3d. So 4s to 3d5. This is the manganese configuration. Next, iron, atomic number is 26. Then 4s to 18 plus 2, 20 completed, then remaining 6 electrons in the 3d. Next, cobalt is also same like that. Cobalt is the 27. 27 means 4 is 2. 18 plus 2, 20 completed. Then remaining 3d 7. Next, nickel is the 28. So 28 means here 2 electrons. Remaining 8 electrons, you have to keep it in 3d. Next, copper. Copper is the atomic number is 29. So argon 18 completed. Then remaining 2 electrons keep in the 4s. So 20 electrons are completed. Then remaining 9 electrons, 3d9. 3d9. But this is also exceptional configuration. Why? Because here 3d9. So totally how many d orbitals are there? 5 d orbitals are there. So if 10 electrons are present, then it is completely filled d orbitals will come. So completely filled d orbitals means that is the stability will get. So that's why from s orbital one electron is shifted to the d subshell. Then what is the configuration? 4s1 3d10. 4s1 3d10. This is the configuration. Next, actually 4 is to 3d9 have to come, but to get the stability, if 10 electrons are present in the d orbital, it is getting the stability. So that's why here 4 is 1 electron is shifted to the 3d orbital. Then 4 is 1 3d10. Next, zinc is the atomic number 30. So argon is 18 completed. Then 4 is 2. 4 is to remaining 10 electrons, you have to keep it in 3d. So 3d10. So these are the electronic configuration of 3d series. So you have to remember, in the 3d series, what are the exceptional configuration? That is the chromium and copper. So chromium atomic number, what is that? 24. Copper atomic number 29. So here 24 electrons, how to fill? Argon. After that, argon 4s1 3d5 is the configuration. 3d5. Next, argon, this is the 4s1 4s1 3d10 is the configuration of copper. So these are the exceptional configuration in 3d series. Next, coming to the 4d series. 4d series. So 4d series elements, what are those? That is the yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, argentinum, cadmium. So these are the elements in the 4d series. So in this, what are the exceptional configuration? Means niobium and molybdenum, and after that ruthenium, rhodium, palladium and argentinum. So these are all having different means exceptional configuration only. So here yttrium, what is the atomic number? That is the 39. This is the 40, like that, 41, 42. Cadmium is the 48. So how to write the configuration? Here what is the nearest noble gas for this? 39. Yttrium is the 39 means, so here what is the nearest noble gas? That is the krypton. Krypton is the nearest noble gas, so that atomic number is 36. So 36 electrons, if you wrote a krypton, then 36 electrons completed. Now yttrium having how many electrons? 39 electrons it having. So 36 electrons krypton we can write. Remaining 3 electrons where we have to fill after krypton, we have to fill the what is that, 5s electrons and 4d, 5s and 4d we have to fill. So for 36 completed, remaining 3 electrons we have to keep, what is that, in s orbital, that is the 2 electrons only, 5s2, and after that remaining 1 electron is the 4d1, 4d1 configuration. Next, zirconium, that is the 5s2, 4d2 is the configuration, 4d2. Why? Because krypton 36 plus 2 and plus 2, so totally 40 electrons. Next, niobium, that is the atomic number is 41, atomic number is 41, but here what is the configuration? 5s1, this is 5s1 configuration, and this is remaining 4 electrons we have to keep in the 4d. So niobium configuration is the krypton, krypton 5s1, 5s1, 4d4. Remaining all the elements will get the 5s2 only, but which are the exceptional configuration? Those are the 5s1 configuration. Next, this is molybdenum is the 42. So here 5s1, 5s1 configuration we have to keep, and remaining 5 electrons also you have to keep in 4d. So 4d 5. Next, technetium. Technetium not having exceptional configuration. So technetium, what is the atomic number? 43. So here 5s2 electrons only. Next, remaining how many electrons in the 4d? That is the 4d5 only. 4d5. Next, ruthenium is the 44. Then this is also 5s1 configuration. Then remaining 7 electrons also you have to keep in the 4d. So that is the 4d7. Next, rhodium, that is 45. This is also exception. So 5s1 keep, and after that 4d8. This is the 4d8 configuration. Next, palladium. Already I told you before only, palladium is having different configuration from other d block elements. Actually, d block elements in s orbital 1 electron or 2 electrons are present, but palladium, only palladium, that is atomic number how much? That is the 46. Only palladium having 5s0 electrons, means in s orbital only 0 electrons are there. Then remaining 10 electrons also present in 4d10, 4d. So what is the palladium configuration? Palladium configuration, krypton, krypton already 36 completed, and after that 5s0 and 4d10, 5s0, 4d10. So totally how much? This is 36, 36 plus 10, 46. So this is the palladium configuration. Next, argentinum, that is the 47. So 47, this is also exceptional configuration. So write down 5s1. Remaining 10 electrons keep it in 4d. So 4d10 this is. Next, cadmium. Cadmium is the atomic number 48. So this is not a exceptional configuration. Write down 5s2. 5s2 configuration. Next, remaining 10 electrons you have to write in 4d. So 4d10. So these are the electronic configuration of 4d series. So here what you have to remember? So here different electronic configuration, means irregular electronic configurations are, one is the niobium, next molybdenum and after that ruthenium and rhodium, next palladium and silver. So these are different configuration, means exceptional configuration in the 4d series. So here out of, except to palladium, remaining having how many how many electrons, means that is the 5s1 configuration. This is 5s1. So you have to remember this one. So 5s1 configuration. In 3d series, what are the 4s1 configuration? Copper and chromium. So same like that here 4d series also, these elements having, what is that, 5s1 configuration, 5s1 configuration. For example, they are asking the rhodium configuration. Identify the rhodium configuration they are asking. So rhodium atomic number how much? That is the 45. Rhodium atomic number is the 45. So write down krypton. Krypton is the 36, 36 completed. then remaining how many? 9 electrons are present. So 9 electrons, how to write? Here krypton, after which orbitals we have to fill? 5s orbital we have to fill, and 4d orbital also we have to fill. 5s and 4d. So remaining 9 electrons. Out of 9 electrons, here this is rhodium, is the rhodium having exceptional configuration. Exceptional configuration, which configuration? 5s1. So write down 1 electron in the s orbital, then remaining 8 electrons also keep in 4d orbital. So then this is the rhodium configuration. Next, one more example. For example, silver configuration you need. So silver atomic number how much? That is the silver atomic number 47. So 47, and this is a exceptional configuration also. So write down krypton 36 completed, then remaining 11 electrons are present, and it is a exceptional configuration, means 5s1 configuration. So write down 5s1. So remaining 36 plus 1, 37 completed, then remaining 10 electrons you have to keep it in 4d. So totally 4d10. So this is the 4d series electronic configuration. Next, after that, 5d series, 5d series electronic configuration. So write down 5d series elements. What are the 5d series? That is the lanthanum, lanthanum. The next, hafnium. Next, after that, tantalum, wolfram, rhenium, osmium, iridium, platinum, gold, mercury. Gold, mercury. So this is 5d series exceptional configuration. Those are the wolfram, that is the wolfram. Next one, platinum and gold. Platinum and gold, these are having 6s1 configuration. 6s1 configuration. Here 5d, here lanthanum, what is the atomic number? 57 is the atomic number. So 57, what is the nearest noble gas? That is the xenon, is the xenon is the nearest noble gas. So xenon, what is the atomic number? 54. So if you're writing xenon, then 54 electrons configuration completed. Now after xenon, what is which one we have to fill? Means 6s and 5d orbitals we have to fill. 6s and 5d. So now in this, except wolfram and platinum and gold, remaining all are having 6s2 configuration only, but wolfram, platinum and gold only 6s1 configuration. So now write down lanthanum configuration. Totally how many electrons it having? 57. Out of 57, xenon is the 54, then remaining 3 electrons we have to fill, that is the 6s2 and 5d1. 6s2, 5d1. This is next, hafnium. Here lanthanum is the 57, but hafnium how much? That is the 72. Atomic number how much? That is the 72. Why? Because in middle, lanthanum to hafnium, remaining elements are present in the F block elements. Those are also called lanthanoids also. So here this is the 72. 72 means how to write the electronic configuration? Here 4f14, from hafnium onwards, 4f14 is the common only. Why? Because lanthanoids 4f14, 4f1 to 4f14 completed, so 4f14 electrons also fill. Then here hafnium having after this is xenon is the 54, and 4f14 is also completed, and after totally how many? 68 completed. 68 electrons. 54 plus 14, 68 electrons completed. Then remaining 4 electrons we have to fill, 6s2 and 5d2. 6s2 and 5d2. So this is the configuration. Next, so tantalum atomic number 73. So then 54 plus 14, 68 completed, then remaining 5, 6s2 and 5d3. 6s2, 5d3. Next, this is the 74. Out of 74, how many completed? 68 completed. Xenon and 4 of 14. So totally 68 completed. Then remaining 6 electrons. 6 electrons, this is the wolfram having exceptional configuration, means that is the 6s1 configuration. 6s1 configuration. And remaining how many electrons? That is the 68 plus 1, 69. Then remaining 5 electrons we have to keep in the 5d5. This is the configuration of wolfram. Next, rhenium is the 75. So how many electrons? 6s2. This is not a exceptional configuration, so write down 6s2 and 5d5. Next, osmium is the 76. Here also same 6s2 5d6. Next, iridium 77. Then 6s2 5d7. Next, platinum is the different configuration, means exceptional configuration. What is the platinum atomic number? 78. So exceptional means you have to write the 6s1. Then remaining how many electrons? 9 electrons we have to keep in the 5d9. Next, gold 79. So this is also exceptional. So 6s1 and remaining 10 electrons 5d10. 5d10. Next, silver, mercury is the 80. So this is normal configuration only, 6s2 and 5d10. So this is a electronic configuration of 3d 4d 5d series. Now for example, they are asking Wolfram configuration. What is the Wolfram configuration? They are asking Wolfram configuration. First of all, what is the atomic number? That is the 74. Means it having how many electrons? 74 electrons. Electron configuration means what? The arrangement of electrons into different subshells in the orbitals. Then totally 74 electrons are there. So 74 electrons, first how to write xenon. Xenon is a, what is this? 54 electrons are present in the genome. So 54 electrons configuration only we can write like a genome. And after that 4f14 completed, 4f14. And next one, Wolfram is a exceptional configuration, so that's why it having 6s1 configuration, 6s1. So totally how many? 54 plus 14, 68 plus 1 complete, 69 completed. Remaining 5 electrons you have to keep it in 5d. So this is the 5d5 configuration. So this is electronic configurations of d block elements. So in this you have to remember, in 3d series what are the exceptional configuration? Copper and chromium, that is having 4s1 configuration. Remaining elements are having 4s2 configuration. Next, 4d series. What are the 4d series exceptional configuration? That is the Nb, niobium. Next, molybdenum, and after that ruthenium. Next, rhodium. Next, palladium and silver. Palladium and silver. So in this, except palladium, remaining all having which configuration? 5s1 configuration. This one. Palladium is the 5s0 configuration. 5s0 configuration. This is 4d. Next, after that, 5d series. What are the 5d series exceptional configurations? That is the Wolfram. One is the Wolfram. Next, platinum and gold. Platinum and gold. So these elements having which configuration? 6s1 configuration. This is. So these are the exceptions in 3d, 4d and 5d series.